When you test your products virtually or in the real world, naturally, you're exploring numerous design options, evaluating how long they will last, and finding out when and where ultimate failure may occur. And it's no easy task. When simulating numerous physics and loading scenarios, collecting and making sense of all the data can be daunting and time-consuming. This is especially the case when the design and analysis tools are disconnected or limited. But there is a better way. The 3DEXPERIENCE platform provides a collection of best-in-class simulation apps built with industry-leading technology, including Abacus and FE Safe, and connects seamlessly with SOLIDWORKS. Atom Analyst is working on the Nemo submarine to help satisfy their safety and certification requirements. When it comes to the battery compartment and skid, he has a few remaining tasks. With a depth rating of 100 meters, it is critical that the battery compartment can withstand the pressures beyond that depth to ensure safe operation. At the same time, weight and cost must be reduced wherever possible. Atom considers the thickness of the steel tube and stiffeners, and defines the associated dimensions as parameters to be optimized. He saves the updated model to the platform and launches the Model Assembly Design app to start the simulation process. First, a mesh is created. The automated FEM recognizes the thin components of the model and creates mid-surfaces and associated shell mesh bodies all in one command. Next, Atom creates the structural scenario that defines the loads and boundary conditions to simulate the maximum designed depth rating. At first glance of the results, it is obvious the structure is over-designed. Atom launches the Parametric Design Study app, selects the parameters and goals of interest, and lets the computer do the rest of the work. When the study is done, Atom can easily interpret and compare the performance of the various configurations. The best design is even highlighted for him, and with one click, a new model and study using the optimal parameters is created, so Atom can take a closer look. But he has additional tasks to complete first. The pressure load on the battery compartment happens multiple times throughout the life of the Nemo. Another loading condition that repeats is the impact of the skid landing during storage. To simulate this secondary loading condition, Atom creates an explicit dynamic study to accurately capture the rapidly changing stresses of the landing cycle. How exactly does the skid come in contact with the floor? Atom lets the solver figure that out with one simple yet powerful general contact interaction. To greatly decrease the solve time, Atom chooses to run the simulation on the cloud, leveraging its high-performance computational power. Atom can even shut down his computer while the simulation runs. The stress values are within an expected range. But how many times can the Nemo withstand both this and the pressure load? To reveal the answer, Atom sets up a durability study. He defines a fatigue loading that captures both events. For the explicit dynamic results, he includes all increments to account for the fluctuations in the response. Atom also includes both stress and strain in the calculation to improve the accuracy and solve for both high and low cycle fatigue. Both sequences occur in the loading history, but they are exclusive events, so he turns off the inter-event transition option. Lastly, he defines the base surface finish and solves for the results. The results are not only available to Atom, but they may be viewed by other collaborators from their internet browser, so everyone can get the latest information instantly from one place. Atom's last task is to identify when and where ultimate failure may occur if the Nemo gets too deep. Leveraging the same study setup from the first scenario, he defines a Rix buckling step, which goes further than the typical eigenvalue buckling analysis. And it's well suited for an unstable and nonlinear collapse of the structure. And it doesn't require setting up a more complex dynamic analysis. Processing the results is simple too. Atom plots the load factor and visualizes which areas of the compartment will fail first. By using the 3DEXPERIENCE platform to explore numerous design options, evaluate durability, and understand critical loading events, Atom and his team were able to make informed, timely decisions to help fulfill their safety and certification requirements.